Hello and welcome to the Management and Operations channel here on DCD. I'm Alex Dickens, Head of Broadcasting at Data Center Dynamics, and I'm delighted to be introducing this topic, which will be exploring lithium-ion fire prevention for data centers, investing in safety and lowering risk. Thank you very much to our sponsor Honeywell for supporting this session. Joining me, we have three expert speakers on all things fire prevention and risk mitigation. Joining me is Maria Maluenda, Senior Demand Generation for European Data Centers at Honeywell, Steve Cummings, Director for Sensors Business Unit at Xtralis, and Derek Allen, Group Director for Operational Engineering and Technology at Global Switch. How are we doing, everyone?
Hi.
Very good.
Thanks for having us.
Thanks for joining. Right, I guess to get straight into it, we're obviously talking fire prevention, batteries, lithium-ion today, but not everyone in the industry is an expert on the history of batteries. Derek, perhaps to begin with, you can help set the scene a little bit. Why do we use batteries, and could you give us a little bit of a brief history there?
I'll try. So the fundamental reason we employ batteries is to store energy. They're a very easy means of storing energy for future use. On the history, they started in 1866 by a French engineer, Leclanche, who set up a cell for the telco industry, used in telegraph, so that they had a constant power supply. And there's been a lot of development. Lead acid was the next big thing to happen, and it's used in a variety of everyday products, not least your car. And lithium-ion is a relatively newcomer, only coming onto the scene in about 1948, just after the Second World War. And then it was superseded by NiCads, which had quite a strong life. And now lithium-ion has come back into the scene with a high power density. Is that the sort of thing you're looking for?
Yeah. But perhaps you could go a level deeper, especially regarding lithium-ion batteries. I mean, you say they're a relative newcomer, although 70 years doesn't seem quite so new to me. But perhaps you could explain the modern use case. What do we need them for?
So they're used in a variety of industries. I know the data center and the telco industry well. We use them to store energy. So when we need energy during power failures and the like, we can rely on that source for an autonomy time. They're used in the energy industry by the network power distributors so that they can assist power output during high density periods and stop voltage drop and frequency dropout. And they're used in the marine industry quite a lot nowadays. As boats come into harbour, they don't want them working on diesel engines, so they use battery-powered motors. So everything from your electric toothbrush to your phone to a torch to tools and bits of technology rely on lithium-ion batteries in different scales.
Mm-hmm, mm-hmm. And perhaps before we move on a little bit, lithium-ion is only one type of option available. Could you perhaps help us understand a little bit more, the other kind of commonly used options and what the other different chemistries are and what the different functions they're used for are?
Of course. So fundamentally, you've got two types of batteries. You have what I'll call primary and secondary cells. Primary cells is your classic throwaway battery. It's not fit for recharging. It's not designed for that. And then you have secondary cells that are rechargeable. And that's fundamentally a chemical reaction, or better described as a reversible chemical reaction. So if you draw power from it, the battery depletes, and then you recharge the battery by pushing electricity into it. And that's the fundamental difference between the two types. And then within the battery itself, there's a variety of chemistries depending on the manufacturer and type of battery. Lead acid is the one that everybody knows, what they call valve-regulated lead acid is the common battery that everybody uses. That's unusual because it just uses lead plates or a variation of lead plates. Most other batteries use two different metals and an electrolyte and a separator. And nickel cadmium, as I said, NiCad was a popular one. One that's coming on the market more and more now is zinc cadmium. Zinc 5 is the brand for that. And then obviously you've got other. There's some sodium batteries and bits and pieces that are yet to be developed commercially.
Mm-hmm. Mm-hmm. Derek, I've got to thank you for the very brief history and chemistry lesson. Steve, Steve, just to move the conversation on a little bit, perhaps you could help now, Derek's really set the scene for us, contextualize the problem a little bit more. I guess the most obvious question and the elephant in the room is, where is this demand for lithium ion coming from, especially within the data center and wider digital infrastructure space?
So I guess when we think about other industries that are around the data center space, particularly from our point of view, Xtralis is the developer and manufacturer of the Lion Tamer system. So we think about it from commonality of risk and differentiation of risk. So Derek spoke a lot about the different chemistries of batteries and different types of batteries. And when we begin to look at what each of those different types of batteries carry with them specific hazards and specific risks that we as, I guess, detection and safety manufacturer look at what is common among those risks. And specifically with lithium-ion batteries, we are looking for ways of detecting failure early. And so as the technology is used in adjacent markets to data centers, we look at things like stationary energy storage for utility, commercial, and industrial applications. So examples of that might be things like renewable energy at a solar field or a wind farm to store excess energy when it's being generated for future demand and future load use. Similarly, an electric vehicle is another great example of that, where lithium-ion batteries are really the primary technology that's being used in those applications. And so in each of those different areas are areas that we've worked in to help address those hazards that we're going to talk a little bit more about as we get into this discussion further.
One thing to mention that I think we've all kind of hinted at, haven't really addressed, is that lithium-ion, although there are other chemical technologies competing with lithium-ion, at the moment, the lithium-ion battery market is the most popular, successful in the world right now. There's simply no competition, whether it is in your phone batteries or car batteries or industrial scale batteries, lithium-ion is really the reigning technology. Although there are alternatives, like Derek mentioned. And maybe I can speak a little bit more about the data center space. I've been working with Steve a little bit on the industrial scale batteries market for about a year. Then I moved on to data centers with Honeywell. In data centers, I'm really lucky to be able to go to pretty much every single data center event in Europe for the past 2 years. And really the hottest topic of conversation for data centers is sustainability. Because data centers just use and demand so much power for the IT loads, sustainability and sustainable systems really is at the forefront of every single event conversation. And lithium-ion batteries are really one of the tools that data centers can use to be more sustainable, not only in backup power generation, replacing diesel generators, but also with primary power. So that's where the interest and the importance of lithium-ion batteries would be for data centers specifically.
Brilliant. Thank you very much. Before we move the conversation on, and as Steve rightly says, we're going to talk a little bit about the risks. But I guess, Maria, whilst we'll stick with you for a moment, and to ask another question, which is a bit of an elephant in the room question, whilst, there are still risks regardless of whatever we use, to pick on lithium-ion for a bit longer, why do we have to take such particular care with this sort of battery chemistry?
As you might have noticed in the news, no matter what use you have for the lithium-ion batteries, whether it's your phone overcharging, overheating, or laptops. I don't know if you've seen photos of laptops where the batteries have expanded and failed. There's also a lot of news of the possible risk of car fires with batteries. They do have that common risk. Basically, inside the battery, there's electrolyte solvent liquid. And that liquid is quite unstable. And when the battery fails, and I'm doing a very, very general explanation of this. I think Steve can probably have a lot more knowledge on this. But when the battery becomes unstable, it starts off gassing electrolyte solvent vapor. And that is very, very explosive and can lead to a fire that it does not act like a normal fire. A normal fire will produce smoke, and it's easy to put out. A lithium-ion fire I've seen videos of them burning underwater for something like 2 weeks. They take very specific deterrents to be able to be managed. And perhaps Steve can give a little bit more insight on this, but it should really not be treated as a regular fire.
Yeah, and when we talked a little bit about the different chemistries and looking at the unique hazards that each chemistry brings with it, and really it comes down to, how do you protect against that hazard? How do you plan for the specific technology that you're utilizing in your energy storage system? And as Maria mentioned, one of the things that makes the hazards of a lithium-ion battery unique is the use of an organic solvent that is a flammable liquid. And that's really where that instability comes from that Maria talked about. So when a cell begins to enter into thermal runaway, that contributes to the hazard and the fire load. And so from our perspective, when we think about protection of these systems, we think about the sequence of failure that occurs, and we think about detection at the earliest point available. When we developed the Lion Tamer system, we really developed it as gas detection specifically for lithium-ion batteries. And what makes kind of that detection unique is it is targeted at detecting those electrolyte solvent vapors that come out ahead of the thermal runaway process starting. So there's other detection for detecting when thermal runaway occurs, things like hydrogen sensors, CO sensors, CO2 sensors, smoke, heat, flame detectors. Really what we're targeting to do is detect that prior to that thermal runaway event to give you earlier warning and allow you to take actions to help prevent that thermal runaway from developing in the system.
Mm-hmm. Mm-hmm.
I would say, if I can just jump in there, and it's any battery is either safe or unsafe, depending on how you care for it. And where the lithium-ion risk exists is because it's such a high power density for the actual physical footprint of the device. If you, I'll use the word abuse, damage the battery either electrically by overcharging, whacking too much of a load on at any one time, or physically doing damage to the thing, keeping it too hot is another risk, then the cell will deteriorate. And part of managing these systems is to make sure that you're trying to prevent the event where you get to thermal runaway by prevention, and then if you do have that, by mitigating the risks. And for me, the key point is early detection, which is what you guys have mentioned, is one of the ways of making sure that you stop the thermal runaway. But if you can stop that right from the beginning by caring for your battery, then you're in a much stronger place.
Mm-hmm. Mm-hmm.
Yeah, so when we talk commonly about risk reduction, we often think of it in terms of what we refer to as barriers. So when we think of a hazard mitigation analysis that, as Derek described, really goes from those pathways that will lead into a top level event, something like thermal runaway in a lithium-ion battery, and then downstream from that, you start to think about consequences of that top level event. We think about what are the various barriers on each of those pathways, and that's where early detection, and specifically electrolyte vapor detection, can be used as a barrier on that preventative side to give you that early warning. So having multiple redundant, independent barriers helps to strengthen and ultimately reduce that risk of the battery within the environment that it's used.
Mm-hmm. Mm-hmm.
Sorry, I just wanted to kind of drive that point home just by saying we've now two of us, well, both Steve and Derek have used the term thermal runaway. So for those who are listening and not as technical, I know when I started in this topic 3 years ago, I didn't really know what that meant. So thermal runaway is such a great term because it means the very specific explosion or fire that you get from lithium-ion batteries. And it's also a fantastic term because it does run away. So once it starts, it's very difficult to put out. And the greatest risk for energy storage batteries, the greatest thermal runaway risk is propagation, either to other batteries or to the rest of the building. And heaven forbid, the people operating the building. So I just wanted to give that small technical note for anyone listening who might be new to the topic.
Because what it is, thermal runaway occurs when you cannot dissipate the heat fast enough, or should I say, you have to dissipate the heat faster than the reaction can develop it. And if you can't do that, you end up in thermal runaway, and it's an exponential heat growth. You can end up with this thing called deflagration, which is a subsonic explosion if you're really lucky.
That's one way to make noise in the industry, but perhaps not the way we're looking to. I know earlier on, Maria, you mentioned, perhaps there's a bit of a bad reputation around kind of lithium ion because, as ever, the stuff which makes the headlines is the kind of biggest and the baddest. But, when it comes to the reality on the ground, Derek, actually, comparing something like lithium ion to other options, whilst you do get perhaps sensationalistic headlines, it's not by any means, the only type of chemistry which needs looking after, or, disasters can happen. I know we've seen examples of that in the past. Perhaps you could give us a bit more detail.
Yeah, sure. So those of you who've seen my bio will realise I've come from the telco industry, and about 1 million years ago when I was at university, I was fortunate enough to work for the headquarters group who were doing a lot of testing. And there's a video which is an old VHS video that's now on YouTube. And the headquarters group at BT actually did some testing and put a short circuit on a what's known as a power equipment rack battery, a 54-volt battery. And about 3 minutes in, that's quite an interesting observation, because this thing actually boils the sulfuric acid out as steam. And then there's an event where the device actually burns. So that's why I'm saying earlier on, any battery is both safe and potentially unsafe.
Brilliant, thank you. Yes, and that will have just played on screen for our viewers, but the full episode or full link on YouTube is available via the link below. But before we move the conversation on a little bit, Maria, perhaps you could sort of hammer home a point for me. A lot of the conversation so far is really focused, on this early prevention, this making sure we mitigate problems early. But speaking about kind of how you develop the product, making sure that you identified methods for it to halt escalation as early as possible. Could you talk about how the Lion Tamer came to be in a little bit more detail? I'm interested to understand the technology.
Yeah, of course. I'll get to that, but first I did want to say that we have talked a lot about the risks of batteries. That's because that's our expertise. That's what we want to do with this conversation, talk about risk reduction. But it doesn't mean that the battery should be, or lithium-ion battery should be considered a risky investment or a risky part of sustainability goals. This is just one of the risks that you face with using new technologies, and we wouldn't want to fearmonger those out there looking into these kinds of technologies, but they should be aware of these risks, because we do have responsibility of building safely as we incorporate all kinds of new technologies. Now, getting back to Lion Tamer. Lion Tamer was developed by Xtralis, so thank you, Steve, for joining this call again. I'm always happy to have your support. It actually started as part of a research project asked for by the US Navy. They had a thermal runaway event in one of their submarines, and they realized that this was something that needed to be addressed, put out a request for a proposal of new technology, and Xtralis answered the call. What Xtralis did after a lot of testing is they realized that for all battery failures that were electrical, so not mechanical, driving a car into a massive battery will still result in thermal runaway, even with these kind of safeguards in place. But when the abuse is electrical, so overcharging, overheating, the first sign of battery being under stress is the electrolyte solvent vapor fizzing from the battery. A lot of the videos that you find online, you can actually hear a fizz pop kind of sound. And that's actually what happens. Through the research that was done with Lion Tamer, perhaps the best point to really remember and take away from this is if you can detect that electrolyte, solvent, vapor escape in the battery. And you have the right protocols in place, like shutting down the battery, removing all power, and offloading the power that's in the battery, you can effectively prevent and stop the thermal runaway process. And that was done through a lot of testing through Xtralis. You can email us, send me a message on LinkedIn, Steve as well, if you want to know the details of those reports. But that's kind of the main point of Line Tamer. You can pull back a stressed battery. A lot of people are going to ask, Maria, my BMS system tells me when the battery's too hot. Or, the battery already comes with these kinds of safety systems. And yes, they do. But Line Tamer is an added safety seatbelt that you can put on the system. You wouldn't not wear a seatbelt because your airbags are installed in the car. So you wouldn't not install Line Tamer to a potential $1-billion investment just because your BMS tells you when the battery's slightly hot. We've seen signals being sent to Line Tamer when the battery temperature is well below the danger levels that the BMS system would track. And that's just, very few errors in manufacturing.
Maria, you teed me up quite nicely to move the conversation along a little bit, giving an example of the kind of work you've done with the US Navy. But I wanted to speak in a little bit more depth about the practical implementation of these technologies. Now, firstly, kind of, again, my burning question was the scalability. We talk about scalability all the time in regard to, pretty much every conversation we have on these broadcasts at DCD. But I'm keen to understand, how scalable these detection systems are, and how they, sort of implemented into different types of operation. Derek, we haven't heard from you for a couple of minutes. Perhaps you could kick us off on this point.
So I can't talk, about industries outside the data center industry with much confidence, but within the data center industry, as processing demands increase, and I don't want to enter the whole debate about AI, but as data processing requirements increase, the power density increases, that puts a greater reliability on the UPS systems to feed power to those systems during events where the mains power is absent, or you're using perhaps an unstable source to power your data center. So the UPS size and therefore the batteries depend on that load. So, if you look at how data processing loads are increasing, it has a direct relationship to the amount of batteries you need to power that. And the reason the lithium-ion is so popular is because of that power density I mentioned earlier. And the risk is, as you put more and more of these power dense batteries into a small space, then the risk of failure increases. So that's where you need to have a system where, if you want to detect the off-gassing early, you have to be able to put enough sensors and enough devices to report that within the system, and we would rely on the specialists to give us that advice. Clearly, we test them because it's not a free-for-all, but we would want to understand how best to protect that. And I guess, Steve, could you tell us how you actually size those systems? Because from the discussions I've had with Maria and their technical people, you can detect it in a variety of places. I've got a specific requirement actually within the cabinets and within the room, but there are a variety of solutions that can be occupied.
Yeah, sure. I can say a few words about that. Just kind of tying back to a comment that I made earlier that it is an independent system from the battery management system. One nice thing with that is we do not need to, electrically connect it to the batteries. Really, you can think of it as a room level detection technology. So we're monitoring the airspace around an installed battery system for the presence of that gas that should not be present. And if it becomes present, then we know that a battery has started to go through this sequence of failure. And it makes the system very scalable. The system is designed to be scaled from, a small single rack of batteries. We put a lot of this equipment into battery energy storage cabinets, so just one rack of batteries. all the way up to the technologies used in battery manufacturing. So in these gigafactories where the cells are actually being manufactured, and you may have a very, very large footprint of detection area. It really is scalable from that small scale all the way up to the large scale. And ultimately what we're doing is we're placing those sensors where that gas is going to be present. And that will depend on the system. Some systems do have design channels for that gas to go to. Other systems may be carried by the airflow within the room. Other systems may be remained within the structure of a cabinet or a UPS system. So there is some dependency on installation. We do have application engineering to assist in that because each battery system is somewhat unique.
Brilliant. Thanks.
And I would add one thing is if you're trying to prevent the system, whatever it is, getting into thermal runaway, you need to be able to see that system outside of the room where the stuff's stored. So please put the devices in the space next door so it's not actually in the space that might be affected.
Yeah, and that gets to another point too, is signal integration. So this is really designed to be a signaling device that would tie back to some either top level BMS or some other system that's capable of electrically isolating the battery system in the event that a off-gas event is detected. So typically, we do recommend a number of actions that are taken when an off-gas is detected. That would include electrical isolation. It would include ventilation where appropriate, and that kind of gets into that downstream consequence if a cell does in fact go into thermal runaway. But then also those personnel alerts, depending again on the proximity of the system to personnel, and that does become site dependent.
I just wanted to say that when it comes to the data center space, the line tamer detector is scalable to all kinds of systems. So I know for data centers, we've got enterprise systems, modular data center solutions, and huge hyperscale size data center buildings, sometimes various buildings on campuses. And line tamer is easily deployable and adjustable to all kinds of sizes. We've actually invited someone who couldn't make it today, and I wanted them to talk a little bit about this, but they've actually installed line tamer on modular data centers. So what those are is a container that is its own data center, and you can buy different numbers of containers, stack them up, and build in a way where the more power you get as you keep growing a site, you can keep adding more of these containers, and that is a perfect use for line tamer. So that's just wanted to make sure we address that.
Brilliant. Thank you very much. I have one final question, which I'm going to put to the floor. Each operation, as you mentioned, is going to be incredibly nuanced and have its own set of requirements. But different systems will obviously have kind of different airflows as well. Given that the line tamer manages or measures gas as its kind of indicator for something perhaps being a little awry, how do we kind of approach different systems and take into account different airflows? Don't know if anyone wants to jump on that. Perhaps Steve.
Yeah, I can take the first swing at that one. So we do, as I mentioned, we have application engineering. So each system we do recognize is unique, and there is a level of application engineering to address things like the layout and the airflow. Ultimately, at the end of the day, line tamer is detecting the venting of a single cell. We're detecting that first cell that's beginning to go in the wrong direction, and giving feedback to the battery system to alert that that cell is beginning to go into thermal runaway or at the first signs of thermal runaway. So while each system is unique, really the target is the same for all systems, is to develop sensor placement so that we can detect that first cell going sideways.
Brilliant. Thank you. Okay. Speaking of going sideways, well, hopefully not, but we're going to talk about the battery ecosystem for this last segment to, really try and contextualize those problems in a little bit more detail, the technologies that are being applied, but also speak a little bit more broadly about what's happening to lithium-ion batteries at the moment and where they're likely to go. I just wanted to take a step back and come back to the topic of safety. incredibly important, but fundamentally, especially when it comes to technology such as this, I'd be really keen to understand, who owns the safety when it comes to batteries? Is it the seller? Is it the consumer? Derek, I'll come to you on this one again.
So, as an operator, there's a legal requirement on you to make sure that the systems you install and operate are safe. We would expect our designers to consider that in the design, and you mentioned earlier about things like airflow, etc., to make sure that we avoid concentrations of gas which would be potentially dangerous. And I'll go back to the lead acid. Even if you're installing lead acid, you have to vent those spaces, because on discharge they'll produce sulfur dioxide, and on charge they'll produce hydrogen. So you still have to make sure you do that design right. We would then expect the manufacturer and the installer to have a responsibility there to make sure they sell something that is both safe intrinsically, and we understand the risks, so that the designer can actually make sure that they're appropriately installed.
It does indeed. It does indeed. Steve, did you have anything to add to that point?
I guess one thing to add to that point is with respect to gas detection in lithium-ion batteries. There's a lot of movement now on code standards, regulation, and insurance. The utilization of this technology, while the technology's been around for many years, as Derek pointed out, the utilization in these spaces and spaces similar to it is relatively new still. So codes and standards are in that process of really developing. We're seeing a lot more recognition of the use of electrolyte vapor detection in things like NFPA 75 and 76, which now do require the use of it with lithium-ion battery systems, as well as on the insurance side. We're starting to see insurance companies really take more notice of it and start to put some requirements in. So I think, there's from that side of it, the codes and standards side, there's a lot of developments that are in the process right now.
Brilliant, thank you.
If I can chime in here, in my very, very humble opinion, I think every stakeholder in a project really is responsible for safety. From the very start, the battery manufacturers do owe consumers the responsibility of that safety. But I think that with every technology, codes and standards are 2, 3, 5, maybe even 10 years behind, just because our technology right now is growing at an exponential rate, just like data centers, and there's no way that codes and standards can keep up. So while we wait for codes and standards to really catch up to the kinds of dangers and risks that we have with this new technology, it's really the responsibility of the owner and the designers and, of course, the installers to guarantee that they're going above and beyond what's required, above and beyond what the industry standards recognize and what they know is the safest measures. We've done a lot of work to work with codes and standards bodies and insurance companies to help them understand the risk, but it's really the responsibility of the experts, installers, to really understand what they're installing. How does it work? What is the risk? What's the danger? And I really have to praise Global Switch and, of course, Derek, because they took on the responsibility and they really owned it. I've met with a lot of owners or data center operators, but I've never met a company that's as knowledgeable as Global Switch. They brought questions to us that no one else had asked before, and that's because they really owned the challenge, they really owned that risk, and they really are interested in retrofitting, reassessing, and looking forward to build safely. Also, again, to battery manufacturers, we are working with, we've got a very good team in China working to include line tamer as part of the standard energy storage component, kind of like an Intel sticker for the Intel chips that you have on your laptops. Line tamer will hopefully eventually be a component in all batteries. But again, as we catch up to get to that point, it's really the designers, installers, and of course end users to take on that responsibility. So
it's a dangerous term, expert, because X is an unknown factor and a spurt is a drip under pressure.
I was hoping you'd say that.
Man, that was quite the setup for that joke, Maria, and wonderfully told, Derek. We are sort of slowly running out the clock, and I've still got a few more questions which I want to put to you guys while you're on the call. We've obviously spoken about the players and who owns responsibility there, but to look at ecosystem from a slightly different point of view, batteries have a very long and quite complicated lifespan. Now, as we kind of ascertained earlier, there aren't as many in the industry as as perhaps other industries who are experts on batteries, and the technology changes quite a lot. So, Steve, to a point you made on an earlier call, we've really got to understand that cradle to grave view on lithium ion. What does it look like, and why is it so important?
So yeah, we, as we address it from a safety standpoint on cradle to grave, we really work in any area where those batteries are used. So whether that's from the manufacturing side, I mentioned, the utilization of the technology for safe manufacturing. As we scale up, we've talked a lot about the growth of the data center market resulting in more systems and the need for safety there. Well, that also, from the supply chain side means more battery manufacturing, the need for safe manufacturing. And then, we work in areas of battery assembly as well. So when we're talking about assembly of UPS systems and the cabinets, obviously monitoring of the systems while they're in use. And then there's been a lot of interest and a lot of discussions in the industry around the recyclability, second life use of batteries. And, there's a lot of challenges there with respect to, that the disposal recycling aspect of the battery. We've done some work in those areas as well, in certain areas of monitoring for storage of those cells once they're out of their primary use. So yeah, there definitely is, the whole industry is growing from cradle to grave for sure.
Mm-hmm.
And there's a need, as you say. So it's before the device is assembled, there's a whole series of components within there which are potentially risky. And again, it's regardless of the technology. And then when the device is being made, there's a risk. As it's made, manufactured, and then stored, there's a risk. When it's transported, there's a risk. And then obviously when it's in use, all of the stuff, you've got the build and then in use. And then at the end, when you dispose of it, you need to make sure you dispose of it in a responsible way. Because any recyclable or rechargeable battery system isn't actually safe until all the components are separated again. Mm-hmm. So all the way through, there's a responsibility on all of the people within the supply chain and or the disposal chain. And we're talking, nowadays battery manufacturers are talking 15-year life for lithium-ion batteries. Typically, we're getting 7 to 10 out of lead acid.
Mm-hmm. And, against this conversation of density as well, you're going to be dealing with density at every single level, presumably, and not only density, but also volume, the amount of stuff you're manufacturing and processing and transporting.
Absolutely. You only got to look at the number of, there's a lot of bad press about electric cars. A few years ago, there were very few. Now you've got a lot more, and suddenly it's a bigger problem, and it makes the news. So
Mm-hmm.
We need to be careful as an industry, as in the power industry that uses this technology, to make sure we adopt it in a safe way, look after it during its use or during its install and its use, and make sure that it's disposed of as safe as well.
Mm-hmm. Mm-hmm. Maria, we've obviously got quite a lot of work to do over the coming years, but perhaps as a way of wrapping up, and I know we hadn't really agreed for me to ask this question, so I do appreciate I'm putting you on the spot rather, but I've got to know, how are we going to balance this innovation with lithium-ion batteries whilst managing the safety going forward against the backdrop of all these changes, all these challenges, and to an earlier point, tech refreshes, that everything's changing every 3 to 5 years. How are we going to manage it?
Well, in my opinion, is always education and staying up to date with the technologies, and really, once again, taking on the responsibility, no matter what part of the project you're part of, whether you're designing, building, investing, or selling these kinds of products. You really have to take on the responsibility of building safely. And again, going above what's standardized, what's required. And then, like you said, the future is green, the future is sustainable, and that sustainable future will include lithium-ion batteries. There's no way around it. We've seen it with EVs, we've seen it in cars. We're seeing it with the growth of PV, solar energy, wind energy, that's all paired with lithium-ion batteries. So it's inevitable that you'll have a quite considerably sized lithium-ion battery near you, if not now, but in the future. But it's just taking on the ownership of that responsibility of knowing what you're installing, your responsibility to the community, to the industry, to not have, fear-mongering PR and stories out there.
If you look in history, one of the biggest ever changes, the Industrial Revolution, was driven by steam. Okay, and if you look at the learning that went on when steam was brought into place, no, I wasn't alive there before anybody asks. The challenge is learning from history and applying those lessons to the new technology so that we get better at doing this stuff faster.
Mm-hmm. Mm-hmm.
And just to kind of reiterate that education piece, just agreeing with what Maria said, I think education, sharing of best practices, I think is another great way for the industry to learn from one another as we develop this ecosystem of codes and standards, as Maria said, that do tend to lag behind. So really appreciate the opportunity to talk about this today and share some of those best practices that are developing in this data center market.
And don't be afraid to reach out to us, because we're always looking into, developing stories, new technologies. So we're here. I'm sure you'll share our LinkedIn. So if you do have any further questions, I just did a really quick chat with you guys on quick line tamer review. So if you want to look at that. And just reach out to us. We'd be happy to look at your standard designs. Like I said, it's a lot of what I do, standardization, scalability of data center designs. I would be happy to help you and, really educate your tech engineering teams if that's what's needed.
Brilliant. Guys, this has been a wonderful conversation, and thank you so much for sharing your expertise. And to our audience, thank you so much for tuning in. If you did miss any of this episode, not to worry, it will be available on demand shortly. And as Maria says, you can watch a deep dive into the Lion Tamer via the link on the bottom right-hand side of your screen. Please do reach out to Maria, Steve and Derek, as well as the wider team at Honeywell if you've got any questions. And of course, us at DCD, we always love to hear from you.